These are three of our four basic log properties. To remember these, basically just remember that logs are powers. For example, if you were asked what is the log base 3 of 9, you would say 2, because 3 to the second power is 9. Notice that this 2 is the power. So a log will always equal a power. So what are we saying down here? We're saying that if we take our arguments and multiply them, we have to add the powers. And that's basically something that we already know. If we're doing x squared times x cubed, what will we have to do? Well, we'd have to add the 2 and the 3, and that will give us x to the fifth. In other words, we'd have to add the 2 powers. What if we were dividing those values, or what if we're dividing x to the fifth by x to the third? We know we would have to subtract the powers, and we end up with x squared. And again, logs are powers. So again, if we're dividing our argument, we're going to have to subtract our powers. Also, if we have something raised to a power, for example, if we have x to the second raised to the third, what will we do to the powers? Well, we have to multiply them. So that's all this rule says. When we have an argument raised to a power, basically you just multiply a power times a power. And so this is how our log rules are going to work. We're going to see some application, but this video is primarily focused on where do these rules come from? How do we know that these properties are actually true? And the fourth rule is the change of base formula, which basically shows us how to change a problem to something else that we can work out on, let's say, a calculator that might not allow us to have a particular base. For example, let's say that we had log base 2 of 38. Well, our calculator might not have a base 2 option. It might just say log or log base 10. So what we want to do is to use this formula to change the base. So log base 10, log base 10, and what goes up at the top is our original argument, which is 38. What goes at the bottom is our base, which is 2. So we just have to put this into the calculator and come up with a decimal value. To prove our first property, let's pretend that a to the m is equal to x, and that a to the n is equal to y. And what would happen if we multiplied x times y? Well, what would happen is we would have a to the m times a to the n. Notice that the bases are the same. So what will we do with these powers? Well, think about what would happen if it were x to the second times x to the third. We know we would have to add the powers, and so that's exactly what we're going to do here. So this would equal to a to the m plus n. Now let's say that we took a log of that. So log of a to the m plus n, and let's say it's base a. So we're asking, what is the power? Well, we can see the power is m plus n. So this is going to equal m plus n. Remember that this whole expression here is the same as log base a of x times y. What about the m and the n? Well, if we did log on both sides here, we'd have log base a of a to the m has to equal log base a of x. So here we're asking what's the power? Well, in this case, the power is just m. So m is equal to log base a of x. And if we did the same thing with n, then we would end up with log of a to the n is equal to log of y. And of course, we're going to keep the base as a. So right here we're asking what's the power? The power is n. So n is the same as log base a of y. Well, we know what m is equal to. We know what n is equal to. And over here we have to add m and n. So we're saying log base a of x plus log base a of y. And so we've proven our first property. We can use the same general steps to demonstrate this. Why don't you pause the video and try and see if you can prove this to yourself. So let's say that we were to try it. So we're going to say a to the m is equal to x and a to the n is equal to y, which means, of course, that if we do a log on both sides, we're going to end up with log base a of a to the m is equal to log base a of x. This piece here, we're asking what's the power? The power is m. So what we're saying is that this is going to imply that m is equal to log base a of x. Down here, if we did a log on both sides, we'd have log base a of a to the n is equal to log base a of y. Over here, we're asking what is the power? The power is n. And so we're saying that n is equal to log base a of y. So if we were trying to prove what's going on here, remember that this is basically a division problem. Think about what would happen if we did x divided by y. So if you do x divided by y, what you're saying is what happens if you have a to the m over a to the n? Well, we'd have to subtract the powers, and we would end up with a to the m minus n. If we did a log on both sides, log of x over y is equal to the log of a to the m minus n. Of course, base a. So this side is asking what's the power? The power is m minus n. So when we see log base a of x over y, it's simply just going to be m minus n. So that means that we can actually start replacing some things over on the side here. So this part right here we know is the same as m minus n. So log base a of x over y is the same as m minus n. We know that m is the same as log base a of x. So log base a of x, and we know that n is the same as what we have here, so minus log base a of y. And so now we've proven our second log rule. This property follows naturally from what we know about the multiplication of arguments in a log. So we know that log of x times y is just going to be log of x plus log of y. So if we think about what happens with an exponent, if I say x to the r, I basically am just saying x times x times x times x, etc., r amount of times. So we can translate what's happening here. So we're saying log of x times x times x times x r times, which according to this rule means that we have to add the logs. So it'll be log of x plus log of x plus log of x, and we'll keep adding that. R times. So remember, repeated addition is basically just multiplication. So this is like saying R times log base A of x. To prove this rule, let's say that we took this portion here and replaced it with a letter. In other words, we're going to say let log base A of x equal to n. So if we wrote this in exponential form, we're saying the base is A, the power is n, remember logs are powers, and the answer is x. So if that's true, then that means that the logs are also equal. Let's say we took logs on both sides, but let's change the base. Let's say this time log base c of a to the n, and that has to equal log base c of x. Remember the power rule for logs. We can just take this and put it in the front. So it'll be the same as saying n times log base c of a equals log base c of x. Now if we solve for n, we can divide both sides by log base c of a, and this whole side cancels out. We just have that n is equal to log base c of x over log base c of a. But remember what n was equal to. N was equal to this. So what we're saying then is that log base a of x is the same as log base c of x over log base c of a.